Thank you so much for having me over virtually. Obviously this is a really strange year, and I'm sure you're probably tired of being told that. I'm going to talk a bit today about basically everything Soren mentioned, talking about first of all, well, what geography is in my own conception. And then I'm going to explain, my journey at Mizzou and beyond, and how geography pulled me in, and what I've been able to learn as a geographer. And then I want to share some of the work that Esri is doing right now, not as an advertisement for Esri, but just to serve the larger point of how important geography is. And lastly, I want to, of course, give some advice on how to be the best geographer you can be. So I think it's really important that no matter what you do with geography, you understand what your own personal definition of geography is. I think each of us who study the field have a slightly different conception of it based on our own experiences and based on the different dimensions of geography that we study. It is obviously a very large, broad, holistic, interdisciplinary field, so much so that much of the work that's considered geography in the academic field is not done by people who have the title geography professor or even have a geography department at the university. Geography is a very wide-ranging field that, for me, is all about encompassing the spatial dimensions of everything. So, to paraphrase the Esri motto, the science of where, geography is asking the how and the why of everything that could be considered a where. We are studying the spatial dimensions of anything on the surface of the Earth, and on, of course, includes slightly above the surface, not quite to the atmosphere, and slightly below the surface, not quite to the bedrock. Geography interests itself with the relationships and causes and effects of everything that can take place on the surface of the Earth, and recognizes all of the things that are on the surface as the product of many different unique competing factors. So to put it a little differently, we have the basic sciences. We have math, physics, chemistry, things that are applicable anywhere in the universe. We have the earth sciences that use these basic sciences and apply them to various facets of the Earth. Geology studies the Earth materials. Biology studies life on Earth. Its component life sciences are zoology and botany, microbiology. Atmospheric science studies the gases that are above us. Marine science studies the water that is around us. All these things are earth sciences in their own right. But geography studies those specific spatial dimensions and how those things interact on the Earth's surface. When you're studying biogeography, you're applying botany, biology, plant pathology, zoology in order to understand the spatial dimensions and patterns and relationships of life on the surface of the Earth. We take atmospheric science and the understanding of how the atmosphere works and combine it with the various ecosystems and the soil and the plants and the human activity that occur on Earth's surface to get climate science, the geographic study of how things interact with the climate and how the climate interacts with the surface of the Earth. Oceanography and ecology are inherently very geographic spatial sciences because they study at scale individual processes that are understood by earth sciences, but apply them in the spatial dimensions to understand how they work in the aggregate. These all dimensions are often called physical geography, and we often refer to them as such, and you might say, oh, I specialize in physical geography. On the other side, we have the social sciences, poli-sci, sociology, econ, history. And those are all concerned with specific studies of understanding human activity, human relationships, human behavior. From that, we also have geographic dimensions. You know, human geography is maybe encompassing cultural studies, or economic geography. How is the flow of capital affected by geography? How is income inequality affected by where you are on the surface of the earth? A lot of human geography involves populations of people, demography. What the Census Bureau does is inherently geographical. And we often term these things human geography. And I think something that is a challenge for geographers is to understand they are not participating in one or the other. Physical geography is because of the nature of human activity, because we are living in the Anthropocene, the geologic era that is primarily dominated by the activity of humans. Physical geography is very affected by human activity, not just in climate change, how we're affecting the climate, but in every facet of human development. It all has something to do with affecting the Earth's surface. Again, also physical geography impacts human geography. I'll mention a little bit, but I had a friend at McGill who her studies were on, she studied in the Peruvian Amazon. She went to a remote tributary of the Peruvian Amazon, and she was studying the livelihoods, the economic activity of the villagers there. But she was studying it after a recent geomorphic event in which a river capture had occurred, in which the nutrient content of the river had fundamentally changed. And she wanted to understand how that was impacting the livelihoods of the people. Oh, sorry. The livelihoods of the people who were in that village. And from that, we know that she was doing a sociological study. She was studying cultural geography and studying economics, but she was also doing that because of a physical geographic event. We know that these two things have to be related, and it's important to study them both. Lastly, we have a set of geographic tools. Geographers do share a set of common tools that we all use. Pretty much everyone who goes through a geography program has to learn GIS. And whether that is Esri ArcGIS or a open source or some other competitor of ours, we're all learning how to use computer-assisted mapmaking, computer-assisted spatial statistics, analytics. That all comes from understanding geography and applying these new tools to understand long-standing problems. We also have the study of epidemiology, which is one of the oldest formal geographic quantitative sciences, going back to John Snow in the 18th century, that we're all taught at some point in our geographic education that John Snow used a map to study cholera. That continues today, and spatial epidemiology has never been more important than this year as we undergo the tracing of pathogens and diseases across the planet. And we trace things like contact tracing and understanding the hotspots. And I will, of course, talk about COVID later when we're talking about GIS, but to understand that as a really important geographic tool as well. All of us engage at some point in the art and science of cartography, which applies map-making skill and design and aesthetic choices in order to better represent what we want to tell, the story that we want to tell to our audience. All these things are very, very different. The studies that I had to take in order to understand my master's degree, I had to learn, geochemistry and atmospheric science and plant pathology, all these things. Meanwhile, my coworkers and my colleagues and friends at McGill were learning about sociology. They were learning how to do population studies. They were learning how to travel and do qualitative interviews. All these things were very different, but we were united in the fact that we were studying spatial causes and effects. We were asking spatially oriented questions and trying to find solutions that were rooted in geographic tools. So of course we have a few terms in common as well. All geographers are asking questions about place and space and scale and landscape, and they have different definitions for each of those terms. For terms that we all use, they're very vague and very controversial. I like to think of place as any position on Earth. That can be anything from a city, if you're studying place relations in a city. It could be a clod of dirt. Whatever that is, that place is impacted by the space around it. If you are looking at a tree, actually, that's the next slide. I will go on. You define space and the amount of space that you need to study using a scale. We define a map scale and the ratio of map scale that we have because we are telling you that the scale is laying down an extent of space that matters. If I give you a map scale of important wildfires, I am cropping that map off of where I think it's important for you to understand. All these things come together in landscape, which basically removes nothing from the map. Where a map might have a set of information, everything exists in reality on a landscape. And a landscape is every factor that might influence a certain place. It is reality in action. So let's put that into context a little bit. Last month, my partner and I were both geographers. We traveled up to Northern California. And one of the places that we went is the Redwood Forest, which is fantastic, and you should all go there if you have a chance. But if you're looking at a specific place, say that I want to understand why a tree is where it is. Often in the Redwood Forest, you see one tree where it is, and it's grown, for centuries, and then you see a line of trees that is in a perfect straight line with it. What's called a colonnade. You have a straight line of 4 or more trees that are spaced out, but they're all in a perfect line. To understand it, you have to study that space. What's around it? What's the different topology of it? What is the hydrology and the climate around it? But you can also notice that at any given time, you also have other logs that have been, trees that have been felled by human activity or by nature, and you can see them decomposing on the ground. Where they are, of course, is a straight line, and those trees have become nurse logs. So they are giving rise to a whole new set of trees, and those trees are growing up in a line, in a straight line. So when you understand the landscape of a forest like that, and you can say, all right, I'm reading this landscape for what it is. I've seen elsewhere that these nurse logs are giving rise to healthy new colonnades of trees that are in a straight line. This, what I'm looking at in front of me of 4 trees that are in a straight line with nothing under them, I am looking at history. I'm looking at the result of a nurse log that's probably been decomposed with no trace of it for hundreds of years. Being able to read the landscape is an essential geographic tool that we are given the full training of as geographers. And that is a really unique perspective to have. Now, I mentioned the map, and I mentioned, of course, we all use maps in our daily lives. We all use maps as geographers. Maps always lie. A map is inherently a misrepresentation or a simplification of what's actually on the surface. From this satellite image of Columbia, or the scale of Columbia that I think is important, we have various representations throughout history of what Columbia might look like from overhead. If I think that the only things that are important are the roads that you see and certain colleges, and I'm going to make the highways look bigger because they are the more important highways. Or maybe I'm going to point out the natural environment. Maybe I'm overlaying a layer of the economic activity or the tax base dependent on zip code. All those things are ways of exaggerating, misrepresenting, simplifying the landscape in order to present a story that we want the user to digest, information that we want them to absorb. All these things are important to understand whenever you're making a map, no matter what story you're telling, whether you're making a map of the Peruvian Amazon, whether you're making a map of the Arctic or of a peat bog. Understanding good map design and the intention behind every map is a crucial part of being a geographer. So let me explain my life in a series of very simplified maps. I was actually born in Colombia. in 1992. And I grew up both in Columbia and Ames, Iowa. Iowa is a very interesting state because people think of it as very rural, very natural. In fact, it is the most biologically transformed state in the Union. It has 95% of Iowa's surface is not what it was, is not the biome that it was when European settlement began. The vast majority of Iowa is cornfields, and it was not that way in the past. We can understand Iowa as put there by glaciation. And I'll talk about that in a bit, but the soil is there for a reason. There's a history behind it. And the human activity that occurs upon it can also be understood as being enabled by its geologic, geographic, soil, and climatic history. When I was a senior in high school, I actually knew what geography was, which I think is pretty rare for seniors in high school to know. Most people who come into geography, at least at Mizzou, transfer to geography after they've come to college, and I was no exception. I started out in journalism, knowing that I also was interested in geography, and then I switched over during my sophomore year. I was taking two classes at the time. I was taking Matt Folk's class on urban geography, and then I was also taking Larry Brown's class on, I think it was human geography of some sort. And from that, I decided, hey, like this is interesting and fascinating enough that I want to do this. I want to learn as much as I can about this field. I had a great time at Mizzou, and I'll talk about that a little more. After I left Mizzou, I knew that I wanted to continue studying geography. And so I looked around for graduate schools, and with the help of Dr. Urban, Dr. Elliott, I was able to apply to a number of places and ended up at McGill University in Montreal. In Canada, it's pretty interesting. The top universities in Canada are public universities. McGill is actually a larger undergraduate student body than Mizzou. And McGill is located right in downtown Montreal. The University of Toronto, University of British Columbia, they're all public universities that are very large, and their research activity is very high. And that makes it a really fascinating country because it's a country that has a lot of public education funding. Imagine that. I attended Montreal. I attended McGill actually on a combination of public funding and private corporation funding, and I'll explain that when I get to my section on graduate school. I had a great time in Montreal. It was a totally different place to live than Columbia or Ames, Iowa. And it was just a really interesting 2 years. Once I left graduate school, I knew that I wanted to get a job. And so I applied to a bunch of different places, and I'll detail that later on. But I ended up getting a job at Esri in Redlands, California. Living in California is super interesting, but for now, I'll just say that the place where I live, the town where I live, was initially a citrus growing empire. Redlands was primarily known for being a citrus growing town, and that history continues to impact it today. So I want to start out again by talking about where I grew up at Mizzou, in Columbia, and in Iowa. When we understand the landscape here, we can see a lot of interesting things. In Iowa in particular, it's shaped by glaciation. At its last glacial maximum in the late Pleistocene epoch, we had a number of glaciations that affected primarily what you see here, what's called the Des Moines Lobe. And these glaciers left behind glacial till that became peat bogs, actually. They became very boggy and wet. The soil in Iowa has been grassland for tens of thousands of years, and going past the last glacial extent for millennia. And grasslands leave behind very rich soil, which has shaped its status as a farming state even today. The story of Missouri is a lot about transportation. Missouri is known for its two great rivers. It was also, as you see on the top right, a major railway state and allowed livestock and crops and people to be moved across the state. Missouri has also used its rivers as an advantage. Lake of the Ozarks, which we know is a place to get drunk and get rowdy, was initially, its reason for being is hydropower. It was created by Bagnell Dam back in the 30s in order to provide hydropower and electricity to electrify the state. And that landscape is largely irreversibly impacted by humans for human activity. These things were things that I didn't quite understand before I came to Mizzou Geography. I understood that Iowa was a farm state. I understood that soil was good. I understood that the Lake of the Ozarks was artificial. But studying geography at Mizzou helped me to start reading the landscape and understanding the history and the various factors that created the landscape as it is. I want to talk about a few aha moments that I had at Mizzou. The first one, of course, I just talked about Iowa and understanding its glacial history and how that plays into agriculture. I also studied with Dr. Urban channelization and the history of river channelization in Missouri, Illinois, and Iowa. Some of the work that Dr. Urban did as a graduate student involved channelization and the history of literally digging river channels to be straighter in order to evacuate water quicker and to make it a more efficient way of draining lands for agricultural purposes, a more efficient way for transport, and as a method of flood control. In Iowa, of course, channelization affects almost every single major waterway in the state and tons and tons and tons of smaller waterways. Iowa was able to become a farm state because of channelization, because of drainage ditches being dug to drain these bogs into something that could be used as suitable for farming. Something like 90% of the surface of Iowa has drainage tiles running underneath it. Just an incredible amount of modification to the landscape. My second aha moment came in a class with Dr. Grant Elliott. It was a biogeography class, and we took a field trip down to Rockbridge State Park, which of course is known for its rock bridge and known for its, its cave, but it's also a place of really beautiful and pristine old growth oak hickory forests. At one point, we were on a trail and we were all walking together, and Grant had us stop. And then he asked us to start reading the landscape around us. And we kind of deduced that, hey, in front of us is this beautiful, open, mature, old growth oak hickory forest. Behind us was a shaggy, dark cedar forest. And talking about it, we were able to understand that behind us was the legacy of a disturbance. It had been farmland until Rockbridge was turned over into a state park in the 50s. And so for the past 60 years only, it had had the chance to regrow, rewild. And following a succession pathway, which is kind of idealized on the lower left here, it had been taken over by grasses and then shrubs, and then some of the fast colonizing pioneers like cedar. And the cedar forest that was there was dark, and it was not well organized, and it was thicker. And eventually it will be replaced by oak hickory forests, like the primary growth forest that we were seeing in front of us, where there's more space and there's a very structured hierarchy of the food web there. That was a real aha moment to start reading the landscape as not simply different types of ecosystems, but as a natural and artificial history that had affected the landscape around it. The last aha moment I want to talk about is what I learned in urban geography with Dr. Folks. Matt focused a lot on St. Louis as a case study because it's a very fascinating case study for urban geography. We talked a lot about race relations and the racially motivated policies that helped shape St. Louis as it is today. Starting in the 1920s, there were racial mortgage deeds and racial housing covenants. And redlining became a very important part of segregating the city into white areas where you can get mortgage and you could prosper, and then black areas which were largely economically disadvantaged. Also, the white flight to the suburbs and the population of St. Charles County and the St. Louis County suburbs and South County was a very important story throughout St. Louis. Therefore, that was in 2012. And therefore, in 2 years later, when Michael Brown was murdered in Ferguson and protests broke out in Ferguson, the national media came to Ferguson. They were saying, well, these black parts of the city are just not well off economically. Because of what I learned in Dr. Folks' class, I was able to understand, no, this is the history. There is history behind this. This is not just the result of different groups of people responding in a different way. This is decades of guided geographic policies that had geographic results. And now in this year's Black Lives Matter unrest and protests and movement and education, I see a lot of my friends on Instagram stories posting those informational cards where they say, what is redlining? Like, what's the history of redlining? That's something that geographers have been understanding and have been talking about for decades. And those things impact the history of the built environment, the understanding of how cities are organized as being the result of policies like redlining are a very important part of studying urban geography. So I credit Dr. Folk's class with helping me understand that tenet of urban geography. So I have a lot more advice coming at the end, but I want to say now, make sure that you're taking advantage of Mizzou's geography's small size. It's a fairly small department comparatively, and that means the faculty are there to help. I was able to develop relationships with Dr. Urban, Dr. Elliott, Dr. Hurt, and be able to help, have their research be something that I could participate in. I was, fortunate to have Dr. Urban as a mentor and to have him participate with me in the honors geography, the honors graduation. And that was really special because he had been able to show me so much about geography during, the 2 years that I was working with and talking to and asking questions with him. Before I left, I helped him out with a study where we were studying people's perceptions of woody debris in rivers. Understanding that people typically see rivers that have wood in them as an impediment, as dirty or needing to be cleaned up. Whereas woody debris in rivers is actually super important to the landscape. It helps decompose, with the decomposition. It helps with habitats for various animals and other biota. Being able to participate in research as an undergraduate was super important. Dr. Urban also pointed me to a fellowship that I ended up getting in Buffalo, New York, in the summer before my senior year. I traveled to Buffalo on an NSF grant, this program that was set up for ecosystem restoration. So I worked for a whole summer at Buffalo doing my own research project in conjunction with two professors, one of geology, one of geography, and we were studying the hydrology at a site that had been an industrial rail canal that had been turned into a wetland park preserve. And we were studying how the industrial legacy of that site impacted the hydrology of the site and how it impacted the abiotic and biotic landscape that was there. Other people who were working with me, other students in that program, were studying biology. They were studying harmful algal blooms in Lake Erie, or studying ways of returning fish to the environment. That was all super interesting to be doing as an undergraduate. My research did not change the world. It did not even get published. I was able to present it at the American Association of Geographers, AAG conference in Chicago my senior year. But it didn't go beyond that. But it was an incredibly enriching experience for me because I learned how to do research. I learned how to ask questions. And I learned ultimately how to direct a research project into finding some sort of conclusion that was supported by a hypothesis. After Mizzou, I knew that I wanted to keep going, and I applied to various different places. And one of the place that ended up accepting me was McGill University in Montreal, Quebec. Montreal is a fascinating city. It's probably the most interesting city in North America because it was settled back in the 1600s by fur trappers, by coureurs de bois, people who were lumberjacks and fur trappers and explorers and people who were just trying to get rich in this unexplored landscape. Of course, the whole time fighting and suppressing and subjugating the natives who were there. Montreal has a rich history over centuries of immigration and cultural change and cultural combat and all these things that writes a really fascinating landscape. And as a geographer who had learned to reading that landscape, it was really fascinating to just simply live in Montreal for 2 years, to ride the metro every day, to be able to go around to different neighborhoods and different immigrant areas and understand and try to learn more every day about the city I was in. Now I want to talk about how what my research did and how it helped. So all geographers work on some sort of complex problem, usually a problem that feeds into a larger global problem. But we all work on it in a small scale, with the exception of people who are combining different studies and bringing them into a larger global context. For the most part, geographers scale down the area of study that they're doing in order to understand a certain level of detail, and then to scale it back up to understand how we can tackle the larger global problem or answer the larger global question. I worked in an ecosystem that's called Peatland or peat bog. Peat is largely found in the northern areas of the planet. A lot of it is in Canada, in Finland, various areas of Europe and Russia, as well as in tropical areas. Without going too deeply into it, a peatland is an ecosystem in which the rate of decomposition is less than the rate of accumulation of plants. So a peatland is an area, at least in the north, where waterlogged conditions of an ecosystem site prevent the plants there from breaking down fully. So what peat is a material, it's not quite soil, it's usually mosses, a specific family of mosses that have been growing for thousands of years. And every year the moss dies and is just slightly pushed down into this material that's called peat. And because it's all waterlogged, decomposition can occur. And that decomposition being arrested means that peat keeps its carbon for thousands of years. That makes it a very boring landscape to look at, but it's a really interesting landscape with a lot of important consequences for the world. Peatlands store like a huge amount of the world's carbon, the world's terrestrial carbon, and they're massive sinks for carbon dioxide and methane. They're also major sources of carbon gas when they are disturbed, such as when they're extracted for garden peat moss, when they are burned to make plantations, when they are dried out or drained, such as they were in Iowa, or when they dry out due to natural climate change. So peatlands are a very important ecosystem that have been understudied and have a very important global context. The research that I was doing at McGill was working on a specific peatland site in Western Alberta that had been extracted for horticultural production. After it had been extracted, they were required by the government to try and restore the site. So they engaged this research group based in Quebec to restore the site and monitor it as it became a functioning peatland again, to once again start being beneficial to the climate, to become a carbon sink. I was studying greenhouse gases both on and under the surface. I was using the equipment that you see in that big white tower, as well as some very rudimentary boxes and chambers to measure greenhouse gas exchange between the plants as they take up carbon dioxide and plants and soil as they release carbon dioxide and methane, to understand whether that restoration effort was being successful. I was able to quantify over a whole growing season the amount of the average carbon exchange, the total net carbon exchange that was made between the surface of the peatland and the atmosphere. That was a super a very difficult way of explaining it. But the larger thing is that I was giving a number about the productivity of some site, its relation to the atmosphere, to the climate. As part of a larger research group that was doing that at sites across Canada and Europe, we were able to put together some rudimentary numbers that estimated the carbon exchange across all northern peatlands. Just a rough guess. That was part of a larger peatland restoration effort that itself was part of the large group of people around the world who are studying peatlands and their relationship to the climate. I was actually able to travel. I presented my research in Boston, Montreal, Quebec City, and Vienna, Austria, where we actually were able to join in a large specific peatland symposium, where they had a number of peatland researchers from across the world who were studying these ecosystems and trying to understand how they relate to the climate. To put that in a more current events context, northern peatlands are definitely endangered, but it's in Indonesia and in Southeast Asia where peatlands are under the most environmental pressure. They're being burned every year, usually illegally, to make way for oil palm plantations. So when I was there, when I was at McGill, I became aware of the fact that I was studying these important ecosystems, but I wasn't studying them where they were the most impactful on the climate. And I began to realize that northern peatlands, the ones in Canada, the ones in Northern Europe and in Russia, were getting tons of funding, tons of researchers going out there and studying and poking and prodding these ecosystems. But there was a relative dearth of activity in research going on in Southeast Asia. If I were to go back and do it again, I would ask, why aren't we going to Indonesia? Why aren't we going to try and understand and perhaps stop or reverse peatland degradation there? And when you look at it in a statistical context, that the emissions, the carbon emissions from peat degradation in Southeast Asia vastly outnumber the ones in Canada. So it's important to always be asking questions of your own field. What are you doing, and are you focusing on the right things? Are you asking the right questions? Now, I was studying at McGill with a fascinating, brilliant group of graduate students. I was working with people who were studying around the world. And while my research was pretty interesting, it didn't even compare to some of the places that my colleagues were going. My friend Lauren, who I mentioned, was studying in the Peruvian Amazon. She spent 2 summers in remote villages, traveling around, interviewing people in their native dialect to try and understand their livelihoods. I had a friend who studied a specific village in Indonesia, a working class or a really poor village of rural peasants that was being forcibly migrated in order to make way for a new master plan city. Another friend was studying the spice trade in Vietnam, on the border of Vietnam and China, and how the various political regimes in Vietnam and China were affecting the lives of ordinary spice farmers in Vietnam. And a number of people at McGill work in the Arctic, which is fascinating and weird and difficult and extremely expensive to get up to and do research on. One friend in particular has an interest in search and rescue. He does search and rescue in his free time. He's an EMT. And he got into the fact that Inuit hunters traditionally go on these long multi-day hunting expeditions. Used to be with dog sleds, now they use snowmobiles, where they go to places that their ancestors have passed down as important indigenous hunting sites. Where to go, when to go, it's all been passed down for generations. Now with climate change and the Arctic being broken up, those places are being affected and changed. And the number of Inuit hunters who have gotten lost in recent decades has really spiked. So his interest in search and rescue got him to start researching search and rescue efforts in the Arctic and how, and starts telling the stories of Inuit hunters who were getting lost because of climate change interfering with their traditional ways of hunting. Moving on from graduate school for a moment, I ended up working at Esri in 2017 after I graduated. And living in California is a really, it's a land of extremes. It's, some of the most beautiful landscapes I've ever seen and that probably exist on planet Earth. Meanwhile, there is unending, unbelievable, unfathomable development and overpopulation that occurs in all nooks and crannies, anywhere that water can sustainably be sourced in California. Not sustainably, but can reasonably be piped in to California. There are developments. There is tract housing. There are single-family homes with two-car garages. And as a result, California experiences extreme natural pressures. Well, this fire season was particularly bad, but fires have been a part of California life forever. And now with people pushing the fringes of where is habitable on the steepest slopes of mountains they can possibly get to, fires are becoming more and more costly. Understanding the fire threat in California is not simply a natural story, or not even just a story of fire management, but as a story of where people are living and how far utilities and roads are having to go, is a really important part of reading the Californian landscape. I want to talk about what I do at Esri, and kind of tie that into what you can do with geography. It's important to understand that geography is very employable. The skills that you're learning now are very applicable across a variety of different disciplines. However, it is very rare that you will have the title of geographer. I know that Census Bureau has some people who are called geographer. I think the Army Corps, maybe the USGS have geographers, but most places you will not have the title geographer, even though that's what you'll be doing. So I applied to Esri with a fairly varied background. I had geography degrees from Mizzou and McGill. I had some background in GIS analysis and mapping from my time at Mizzou, and general conceptual understanding of GIS. And then I had a background in journalism. I was an editor at the Maneater, the student newspaper at Mizzou, for 4 years. And that was a fun time. And we put out a paper of varying quality, but it taught me a lot about journalism, and I became a better writer because of it. Writing a thesis introduced me to the art of technical writing and writing for a specific audience who needs to understand things in a very technical way. Because of that, I was able to land a job at Esri as a technical writer. The chief activity that I do at Esri is write. I work with a team of software engineers, product engineers, and developers, and with product managers and people who are going out in the field to work with clients and marketing people in order to craft the most helpful documentation for Esri software that I can possibly manage. That combines all the things that I've done. And ultimately what I'm doing is in service to geographers across the world. I work for the ArcGIS Enterprise team, which supports most of the organizational work, the defense agencies and city and county governments, national governments. We often work with UN, large Fortune 500 companies. They all need these large implementations of GIS with server machines that are able to handle the amount of GIS that they're doing on a daily basis, and to provide security to their GIS and their important data. So that's the team that I work on. But in that role, I've been able to see what geographers do all around the world. And that's been really fun and interesting to be a part of. All these different things involve geography. This was just a brainstorm of the different roles that employ geographers that have a very important geographic context. In all of these cases, you're asking and answering questions about geography, about where things are on the surface of the earth and why they're there. So a note about GIS. I did not spend a lot of time at Mizzou studying GIS. I think I might have been the only person who graduated in my class out of like 50 with a geography major who did not have the GIS certificate. And I'm very sorry to those of you, to Clayton and whoever else, but I simply did not see it as important at the time. It was of course important for me to know and understand how to do in a rudimentary way, But I saw myself as an environmental physical geographer. I wanted to do research. I wanted to be out in the forest. And so that's what I focused on. The GIS work that I did at Mizzou got me a job. I was able to explain what ArcGIS is. I was able to explain concepts like a geodatabase and spatial data strategies. I was able to know, what a buffer is and the various spatial statistics and spatial analysis tools that are available. And that's the most relevant stuff that I do today. However, the stuff that I learned elsewhere in environmental and physical geography classes continue to interest me and continue to inform my daily work at Esri. GIS is not the only skill that you need to have to be a geographer, but it is very, very important because almost everyone who does geography at some point touched GIS. Most of you have probably seen this specific map. It's actually a dashboard. This uses ArcGIS software to tell a very critical story right now. It was created at Johns Hopkins by a professor and her doctoral student back in February or early January, before COVID was known to be in America. And even before then, within the first week or so, it was getting billions of hits. It became very quickly the biggest, by far, piece of GIS data, the GIS product that was being accessed on ArcGIS servers. It is a really good use of GIS. It uses the ArcGIS dashboard software, which allows you to combine one or more maps with number counters and lists and graphs that all are automatically picked up or automatically derived from the map data. From that feature layer that's assembled from all these different layer sources, we get those number counters that are automatically updated based on whenever the feature layer gets updated. And that dashboard has now had trillions of views and is the gold standard for measuring and reporting and storytelling about GIS. Companies and businesses and organizations and governments and agencies and universities around the world are copying that dashboard and using ArcGIS dashboards to present data, to make people informed, to help them make better decisions and make informed decisions about what to do with their resources, with their cases, with their health workers. They're able to understand how it might affect their business, their transportation, whatever it may be. These dashboards are becoming ubiquitous, whether or not they use Esri ArcGIS software, because they tell a complete story in a way that anyone with a few minutes of poking and prodding can learn to use. COVID-19 has been really important for mapping in general, because more than ever, we are understanding the virus as a geographic issue. We want to know who has it in our state, in our county, in our census block. If I go to the store, do I have a risk of catching COVID? If I go to that store, do I have a risk of catching it? Where can I walk? What sidewalks are wide enough for me to social distance? Who in my city is at risk and where? Where are the supplies? Where can I get food? Where can I get a mask? Where can I get a COVID test? All of those questions are geographic questions. And to answer them, we need geographic tools. That's why all these beautiful maps are using GIS to essentially answer questions about the coronavirus pandemic and its effects. Where are the clusters? Where can I go for this or that? Who is at risk? Where are my resources? Where are my workers? All these things ask geographic questions to answer geographic problems. Beyond that, GIS is continuing to expand and grow. This morning, Soren asked about what's the next frontier GIS, and I said it's about real-time data, big, massive amounts of data. Where are all the mangrove trees in Southeast Asia, and where are they being conserved? How can we take satellite imagery and drill it down into a raster analysis where we can derive a map helping us understand where to focus our efforts? It's about real-time tracking in 3D. Where are all my taxis or ships? Where are those fleets? Where's my garbage truck? In Iowa, there's a really popular map that shows all the snow plows in Iowa in real time. That's something that people need to use every day. When is my sidewalk, when is my road going to be plowed? For census workers, they've had a really successful year in terms of GIS because they planned early and had a very robust system that allows them to know exactly who's responding to the census and where they need to guide their efforts. Of course, they've had a really difficult year for reasons that are not related to GIS, but GIS has helped them do all of the work that they do for the 2020 census. In short, I've said this about a million times, but every map answers a geographic question. These questions are an essential part of life. Even if we're not geographers, we want to know, where are things? How do they relate to each other based on where they are? Why are they where they are? What factors put them there? How does a thing being where it is affect other things that are neighboring to it? Bringing in Tobler's first law of spatial autocorrelation, things that are nearer to each other impact each other a lot more than things that are further apart. And then lastly, the fourth dimension of time. How do things change based on where they are? How does a certain place in time change as a result of different factors and agents that are acting upon it? All these things are essential questions to us as geographers and are a really important part of life. Now, do I have time? Can I keep going?
Yes, please.
Okay.
Advice would be very much appreciated, I'm sure.
Sure. Advice time. So I have some advice to give on school and beyond. I want to talk about the various experiences that I've had and things that I want to impart on you as majors on what to do. The first thing is your years at Mizzou. It is a really fascinating period of life. It is a period of an immense amount of opportunities on campus. And of course, COVID puts a huge damper on that. The ability to gather in person. Mizzou's campus is iconic. It's a wonderful, wonderful place to be. And be able to truly engage with campus, I'm sure is a real downer. Mizzou has so many opportunities for you to get involved, both inside and outside your major. If you get involved, at the very least, I would urge you to get involved in something with your major, with geography, whether it's geography club, GTU, doing an independent study with a professor, whatever it may be, and something outside your major, whether that's a service organization or an interest group or the Maneater student newspaper or a different club that has some sort of your passion. All those things enrich your college experience. And your college experience should never just be going to classes and writing tests. You should always try to take advantage of the other things that are around you because it will help you as a person and it will help you as a student. And yet, eventually, it will help you as a future employee. Indulge your curiosity during your time at Mizzou. There are so many things to get involved with. I was able to indulge so many different things that I'd always been fascinating about at Mizzou: forests and rivers and population and migration and cities. All those things are covered by geography. But I also ran out of geography classes to take by my senior year. I had literally taken them all, and so I had to take other things. I took random classes that I probably will never have the opportunity to learn about again without spending a significant amount of money. I took History 48 something, Age of the Reformation with John Freimeyer, and I will never use any of that knowledge in any context that is important ever in my life. I will never have to respond about the differing German religious approaches in the Reformation age. But it was really interesting, and it allowed me to indulge my curiosity. Next, make sure that your professors know who you are and that they understand what motivates you and what you enjoy doing and how you can possibly, how you can make the most of your time at Mizzou Geography. That's super important. And as I mentioned, Mizzou Geography is a fairly small department. That means that your professors are able to spend time helping you, answering your questions. I asked so many questions of my professors at Mizzou, and I wish I had asked more. There's so much to learn from them because they have all gone through academics. Many of them have worked in the private sector and in the public sector, and they can answer and help guide you to the best career possible. Next, build a network. That is the worst, the most cringiest piece of advice. Building a network is often not fun. It can often feel very fake, but building a network of genuine connections of people in your field is really important because that will help you understand your field better. It may help you get a job or land a position. And the best way that you can often build a network is going to a conference. Particularly at the undergraduate level, conferences love to have you. They love to have students. I attended AAG in Tampa, and then I attended it in Chicago as an undergraduate. Both times, I was able to attend at a very discounted rate. And one year, I was able to have Mizzou pay for my flight and hotel. People love to have students go to conferences because they are helping train the next generation. Whether it's academic, AAG has a wide range of geographic study, or it's professional. The Esri UC is perhaps the best place in the world. The annual conference in San Diego is the best place in the world to learn about GIS and expand your GIS horizons. No matter where it is, talk to your professors and say like, hey, I would love to attend a conference of some sort. That will help expand your network. You'll meet people, you'll attend sessions, you'll learn a lot. And that will ultimately help build the network that you have and the skill base that you can bring into the next stage of life. Graduate school. Do not, under any circumstances, go to graduate school unless you have a really good reason for doing so. In most cases, that means having knowing that you are going to be fascinated by the subject material that you're going to study. Don't go to graduate school because it's the next thing, or because you don't want to get a job, or you don't know what else to do, or your parents told you you should do it. Go to graduate school because you have a very good reason for being there, because it is a very challenging time. Most of your professors will probably say graduate school can be an intensely isolating experience because it is entirely incumbent upon you to do all the work. I took classes for my first year of my master's and wrote papers and that kind of thing. I did my research after my first academic year, and then I came back from Alberta in September. From that point until I turned my thesis in, I had no obligations. The only things that I was doing was writing my thesis, doing my research, doing my analysis, writing my thesis, and then attending conferences and presenting it. It is very self-motivated. It's completely different from undergraduate. And if you are not excited about what you're studying, it can be very, very challenging. It's going to be challenging no matter what. My next piece of advice, if you want to do graduate school, is try to understand the process. Reach out early. Graduate school is very important to work with a specific professor. You're working with a supervisor, and they are guiding your research, showing you what to study, who to talk to. They are often the ones who are providing your funding. And so understanding the process beforehand is super important. You can pay for grad school a number of different ways. The most common is probably being a teaching assistant, which means that you'll be spending a lot of your time teaching. You can also get a research assistantship, which is what I got. And that allowed me to not really have to worry about money as much. I learned in my last semester at McGill that most of my cohort had not been paid minimum wage from McGill. Most of the students had to have some job outside of university in order to pay for their graduate studies. I was very lucky in that regard, in that I had talked to a professor who said, hey, you seem to have the right skill set for this project that I'm working on in this peat bog in Alberta. We have a mix of public and private funding in order to pay for someone to go out there for a year and do this research. I can pay a stipend for you to live. It's not, I wasn't wealthy by any means. It was just enough to live, but it still took an incredible weight off of graduate school for me to be able to have that funding. So understand the process. And again, your professors here at Mizzou can help you walk you through that and help you understand whether graduate school is a good thing for you or not. Lastly, just as an for undergraduate school, and maybe more, your mental health is a priority. Graduate school can be a very intense and challenging time, and keeping a life outside of school is very, very important. I developed an interest. Of course, I spent a lot of time walking around the city. Something else that I got involved with was hockey. In Canada, it's a very, very serious thing. And I tried to join the intramural hockey team for my department. The very first practice, I broke my arm. And I went to, it was right in December. I broke my arm on a Saturday, and I had to take the subway back home. And I realized that I did not have the right insurance card to be treated at a Canadian hospital. And the office opened on Monday. I had a final presentation due on Monday morning. So I typed out the presentation with one hand, with the other arm in a sling that I got from the store. And on Monday morning, I went in with my arm in a sling. I asked to give my presentation first. I did it. I think I got an A. I can't remember. And then I went to the hospital with a broken arm. Having that kind of adventure is part of the fun and the mischievous stuff that goes on in graduate school. Can be really interesting and makes life more than just going to class and writing papers. I would not advise to break your arm in a different country, though. Next, many of you, judging by my graduating class, almost everyone got a job in GIS after we graduated. You are very lucky in that you are attending a university in a state that has a very vibrant geospatial industry. St. Louis is one of the biggest cities right now for geospatial. Part of that is because of the National Geospatial Intelligence Agency, the NGA, which is based in St. Louis, and the cottage industry of geospatial consulting and specific applications of GIS companies that are popping up in St. Louis. I can neither confirm nor deny that next year Esri is going to be relocating me to St. Louis in order to help support that industry. That is all unconfirmed as of yet, but St. Louis is a really great place to be a GIS person. That being said, the job market is tough. The job market can break you down. You will probably have many, many rejections. After graduate school, I knew I wanted to get a job in the private sector. I applied for over 60 jobs, and I was rejected from all of them, and only a few of them even sent me word that I had been rejected. Most of them were just sent into the ether, and I never heard back. You should still apply, because that's really important to helping you understand what you want to do and getting your name out there, and you never know where may need you. Try to make meaningful connections. At Esri, the only job that I ever had a really good shot of at a job was at Esri, because I just happened to be looking for jobs, and I was looking at the Esri website, and I saw a job that combined writing and geography. I applied for it, and then I realized that I was going to AAG that weekend. So I flew to Boston from Montreal, and I was wearing a suit on the plane. I got off the plane, I checked into AAG, I went straight to the recruiting desk, and I found the person from Esri, and I said, here's my resume. I just applied to this job. Can you help me get it? Can you help me talk more about it and connect with people there? That was, it was terrifying, to walk up wearing a suit and to try to basically cold call into a job. I went home and I found out that Esri had automatically rejected me. The HR person in charge of the initial screening had rejected me for that job. I was not a match. But a few weeks later, that recruiter that I'd met called me and said, hey, we have this other job that we think that you might be good for. That was the job that I have now. And as soon as I applied, I had someone call me the next morning. Having a meaningful in-person connection greatly increases your chance of at least getting a foot in the door. And conferences, of course, are a really important way to do that. Trade shows, recruiting, job fairs, all those things are great ways to meet people, which ultimately is going to help expand your chances. When you're applying for jobs, make sure you're advertising everything that you can do. I didn't just say I have a geography background. I said I have a journalism background. I have years of experience with different types of writing. I know how to write for any audience. And that ultimately helped get me the job that I have now. Ask questions of the jobs that you're applying for as well. questions that matter to you. It was important for me to understand work-life balance. Given my experiences in grad school, I knew that you need to have both. And I'm fortunate that Esri is not one of those go tech jobs. It's very important at Esri that we all have managed lifestyles and that we are able to balance what we do. Lastly, when you land a job, make sure that you're advocating for yourself. You should have a manager who goes to bat for you and who provides you with opportunities to build your career, professional development courses, promotions, opportunities that help you expand your horizons. You're not just there to do a job, you're there to build a career, and hopefully the people around you will help you get there. My last set of advice is about life. Even if you never get a job in geography, no matter what you do, being a geography major helps prepare you to be a better person, a more curious person, a more passionate person. You have a unique perspective that we've been talking about with reading the landscape, with understanding spatial causes, with studying these things like how are cities organized, why are forests where they are. So read those things, take time to when you're looking at new places, when you're walking around, try to understand it from a geographic perspective. One of my early aha moments as a geography major was pretty soon after I had switched, and I'd been taking urban geography and a few other classes, and I was on a flight and I was in the window seat and I looked down and I realized that I was able to explain a lot of things in the landscape. I knew about township and range systems. So I knew how the grid system of the landscape below me was organized. I knew about where the towns were, the county seats. I was able to read the terrain and understand the hydrology that's driven by topology. All those things make it super interesting to be on a plane as a geographer. That's a unique thing that we're able to do and appreciate. Try to set yourself up for aha moments. I mentioned that my partner and I took a road trip through California. We saw the redwoods and we also went to wine country, which is another one of our new interests. And the whole time we were geeking out because we're both geographers, and she was able to point out, the nurse logs, and I was able to point out some of the disturbances that resulted in different ecosystems and different borders. When we were in wine country, we were able to talk to people about soil and talk about climatic, microclimates and slope and aspect. All these things that we had learned in our classes made life more interesting for us, made life richer for us, because we were able to take that class perspective, that coursework, and apply it to what we were seeing around us. And with that, do not forget to enjoy yourself. As a geographer, we are able to understand the world around us in a variety of different and interesting ways. And that can make life a lot more enjoyable. So I'm always available to help if you have any questions about working for Esri, going to graduate school, doing any of those things. Don't hesitate to reach out. I'll give them my email. You can follow me on Twitter, where I tweet exclusively about ArcGIS Enterprise and Server GIS. And I'm also available on LinkedIn. With that, I'm happy to answer any questions you may have. And I really thank you all for your time. I know I've gone over the time limit. So thank you.
Thank you, Scott. That was great. I really enjoyed the advice at the end and the effort and the wisdom that you put into that presentation. So we have a question from Mike. Are you still playing hockey?
Not at all. I have not touched hockey. I actually became the hockey coach. So the team, no other team had a coach. But my team asked me, hey, do you want to coach? And I didn't know nothing about hockey. But I dressed up in a suit, and I usually was drunk, and I showed up to the games, and I was just yelling the whole time at the team, skate harder, shoot, whatever I could manage. And I was kind of the team cheerleader.
Showing up in a suit seems to be your secret.
Yeah, I haven't worn a suit in 3
Question
years.
from Dina, I guess.
Yeah.
Yeah.
So you, Scott, you mentioned like you would go to like conferences and networking is like the most important thing. Do you think it was most important to network with like colleagues, like people your age, or like the people like giving the jobs?
It's both. like for example, the first AAG I went to in Tampa, I was, just interested in learning about like biogeography. And literally the first session that I happened to stumble into was given by two people whose work I had studied in Grant's class. One person who'd written a textbook, and the other person had written one of the essays that we read. And I talked to their graduate students. I wasn't going to go up and talk to them in person, but I ended up meeting their graduate students just over the course of the conference, and I was able to talk to them about like what it's like to be a graduate student, and eventually through both of their graduate students, I met those professors and talked to them as well. You should not overlook talking to colleagues, people your age, other students, coworkers, whatever it may be, because they can help you, first of all, understand where you are and what's good to do. And they can also put you in contact with the larger, the supervisor, the professor, whoever it may be. So yeah, I mean, and of course, conferences are a lot more fun when you're like hanging out with people your age and, talking with them and going out and that kind of stuff.
Seth, you had a question, I think?
I was actually just going to say that I have a couple of students here to ask questions as part of their assignment for extra credit. And so Dina already took care of her duty there. But I believe I have Susanna and Alexis here to ask questions. So here's an opportunity for those two to speak up if they'd like.
Maybe they don't have any questions. Does anyone have questions for Scott before we adjourn for the evening? Questions? Susanna doesn't have a question, but she loved the presentation. And I'd just like to say on behalf of all of us, this has been an extraordinary presentation. I know the honors section of Regions and Nations this morning really enjoyed the presentation that you gave. And just speaking for myself, and I think at least more than a few of us here feel the same way. It's sort of re-inspired me about, what geography is all about, and kind of reminded me of all of that, and your advice to undergraduates and graduate students is spot on. So on behalf of all of us, could we give a big thank you, Mizzou?
Big MIZ.